Welcome to a lesson on linear regression. So linear regression typically comes up pretty early in topic 4 of stats and probability, and it's a pretty simple concept, but we'll just go through it. So to set the scene, what is linear regression? Linear regression is basically a model that estimates the relationship between two variables. So this could be age and weight, age and height, basically anything. And if you think about it as a line of best fit. So a line of best fit that tells you how correlated X and Y are. Now, there is a measure of this linear regression to tell you how strong that relationship is, and that is the Pearson's product moment correlation coefficient, R. So we always relate to it as R because that's a pretty wordy name, but it's basically a measure of the linear relationship between variables. So it tells you how strong is X related to Y, if that makes sense. So yeah, hopefully this will make more sense in a bit. But as I said, R has strengths, and the way I find is best to think about it is think of R as a number line. So the closer R gets to either 1 or -1, the stronger the relationship between X and Y. And the closer it gets to 0, the weaker the relationship is. So you always want to be close to 1 or -1. Now, there are questions which will ask you, like, interpret R, what is the meaning of R? So if you get an R value and it goes between 0.025, you can just say that it is a very weak relationship. If you get it from 0.25 to 0.5, you say it's a weak relationship. If it's 0.5 to 0.75, you say it's moderate, and 0.75 to 1, it's very strong. So what you have to keep in mind, and that I've put here, is that you can also get -R. This simply means that the relationship is negatively correlated. So if it's a minus, if R is minus, your line of best fit would just look like that. Whereas if R is positive, your line would simply just look like that. That's all it's saying. Yes, it can be negative like this, but there's still a strength to it, which we have to keep in mind, and that's why it's minus. So all of these here could also go for minus. It could be -0.25, 0.25, -0.75. Now, let's just take this out. Now, if you draw this, because I find it much better to visualize it, let's look at this. So let's say you're looking, let's make this blue. Now, let's say you're looking at this here, R equals 1. If I were to draw a line of best fit through all these dots, I could easily do that. It's perfect. All the dots basically fit on that line. So R equals 1. So if I was asked to interpret what is R equals 1, I would just say that it is a positive, very strong relationship between whatever the X is and whatever the Y is. Now, if I got 0.8, and if I were to draw a line best fit, yes, I could do that, but you see, not all the points are exactly on the line. They're around that line. So it's not perfect, it's not as strong as 1, but it is still very strong if you look up at the key here. So if they asked us to interpret that, you just say it is a positive, still very strong relationship between X and Y. Now, if they asked us to interpret 0.1, if I were to draw a line of best fit, I could technically not do that. There's no real way of drawing a line of best fit there. So if I look at the key here, I would say it's a very weak relationship. So I just say it's a very, very weak relationship. Now, if we look here, R is equal to -0.8. If I were to draw a line of best fit, this would go down. It is a negative correlation, but it's very similar to this one here that we did. R equals to 0.8, it's just that it's negative. So we would just say that it is a negative, very strong relationship. I hope that makes a bit more sense, but we'll find that doing practice question is typically the best way to put this into practice. So let's just do one of those. Now, here is the question. I do always think you should read the question. I know it'll feel like you're wasting so much time, but in the end, this is AI, it is application, so you do need to understand what's happening. So I do advise reading that through before we start. I have, so I'm not going to read it out. But yeah, let's get into it. So we have a warm-up time, and we have a percentage score. Now, so basically we know that X is warm-up time, Y is percentage score. If we look at question A, it says, write down the value of the Pearson's product moment correlation coefficient. Basically, what that's just asking is, how strong is the relationship between X and Y? You have to quantify that. And the way we do this is all with our calculator. Now, I can't get a calculator up on here, but I have written it out here. What you want to do, you want to go into list and spreadsheets. You want to go into input, you want to input your data, just as I have done here. Put your X going down and your Y going down. What you want to then do is press menu, 4 stats, and 1 stat calculations, and then number 2, 2 variable statistics. Now, just to highlight, the reason we say 2 variable statistics is that we have an X and a Y. Those are 2 variables, warm-up time and percentage score. So just to clarify that, if that didn't make any sense. So put those in. When you press 2 variable statistics, it should bring you to this page here. Just put X into your X, Y into your Y, and press OK. Ignore everything else. What should technically come up are a bunch of different answers, but scrolling down, you should see the letter R. Now, hopefully, you've gotten R is equal to 0.72849 ... whatever. Now, because this is a IHL math, you always want to round it to 3 significant figures, so we just have 0.728. Now, here it says write down the value. So the value is simply 0.728. Now, this question hasn't asked it, but you technically have to interpret that meaning. A question may be like, interpret the value of your R. And if you look back at this that we did before, 0.728 is basically in this band here. So we would say it is a positive moderate relationship between the warm-up time and the percentage score. And that's it. Now let's go to B. B says write down the equation of the regression line Y on X. So what this is basically asking, just find the line of best fit between X and Y. Once again, your calculator will do it all for you. And I've written here what you have to do. Just go on menu, 4 statistics, 1 stat calculations, and 3 linear regression. Now, you will end up getting you'll get M and B. Your calculator typically gives you M and B, which can seem a little strange, but your Y equation is simply Y equals mx plus c. All your calculator has done is they've made a B basically your C. That's all you have to remember. The M stays the same, that's your gradient. Just remember that your calculator correlates B to C, so don't worry if it just gives you B. So you should get that M is equal to 0.406990 ... 3 significant figures, 0.407. And then you should have gotten that B, or C in our case, is it should be 41.58193, and you want to round that again, 41.6. Now, the question is write down the equation of regression. So all we got to do is piece that together. Y is equal to 0.407x plus 41.6. And that's it. Now, question C. Use the regression equation to estimate the percentage score the student would get after a warm-up time of 11 minutes. If you want to look at what it is asking is, they have basically given you X here. They've given you the warm-up time. So what they are asking you is to find the percentage score. They're asking you to find Y. So all you have to do is input X into the equation we just got. Now, I want to remind you that when you are carrying out equations from numbers that you've rounded, always try to keep those numbers with as many integers as possible, because you will lose accuracy if you calculate with the rounded version. So if I were to do this, you'd want to do y is equal to 0.406990 by 11, because that's your x, plus 41.58193, and that should hopefully give you 46.1 rounded to 3 significant figures. So, second part C is state whether this estimate is reliable. Now, this is important and you will get it quite a bit, so let's talk a bit about it. We have two things in math, and it's basically, one is called interpolation, one is called extrapolation. What you need to remember is interpolation is reliable, extrapolation is not reliable. This will make a bit of sense, hopefully. So, look at this made-up scenario that I've made. You have your x, your y, and here are all the points I've plotted. So if we were to draw a line of best fit, it would probably go like that, right? That's the overall trend. Now, we only have x values from 3 up to 7. So our domain, so our x values go from 3 to 7. As you can see, 3, 7. Whatever is inside of our x range domain, we can call interpolation, which is reliable because we can confidently assume that any point, even if it was 4.5, even if it was 6.5, anything in that section, this line and this trend will continue as it is. However, if we look past 7 or past 3, so if we go outside of the x domain, so all of this area here and this area here too, we are basically assuming that this line will continue on. This line could simply just drop like that. It could simply curve up. You actually never know, so it's just an assumption. That's why we're assuming that this trend continues for all of the values of x that are past our range. So, I mean, if there's another way you want to imagine this, imagine a person. They're at a theme park. There's a building right in front of them. Some windows. Now, there is a roller coaster. Let's make it blue. There's a roller coaster. It starts here. It goes up. It's going up. It's going up. It's going up. But past this building here, they don't know what's happening behind this building. The roller coaster could loop back. It could simply loop down and back. You never know. So it's basically an assumption. That's why we say it's not reliable. Now, if we go up to a question, it says, state whether this estimate is reliable. So we used x is equal to 11. Now, if we look up here at our x values, our maximum x value is 58.4 and our minimum x value is 12.6. If you want to write that out down here, you can say 12.6 to 58.4. 11 lies outside of that range. 11 lies outside of it, and so we call that extrapolation. Not what I was writing there. you call that extrapolation. Therefore, it is not reliable. So all you have to say is no, not reliable, because you are extrapolating results as 11 is smaller. Let's make some space. As 11 is smaller than 12.6, which is the minimum x value. And that's it. I hope that made sense. Ignore this last question here. That is a completely different topic. But yeah, I hope that makes sense. My final piece of advice is just remember this little grid here. It's really okay. And just remember your R value. And you should be good. Good luck.